Hello, and welcome to Sleepy Starlight Channel. I'm so glad you're here tonight. Maybe your day was long, or maybe you're simply looking for a calm voice to help you unwind and drift into sleep. Tonight, we'll take a gentle journey where science becomes a story and curiosity leads us softly into dreams. In the beginning, there was fire. Not the gentle flame of a candle or the warmth of a hearth, but oceans of molten rock, a planet being born from chaos. The young Earth glowed like a star, its surface a sea of magma, its air thick with vapor and metal dust. Around it, fragments of the early solar system collided and fused, falling like rain made of stone. There were no oceans, no skies, no life. Only heat and gravity, the two great architects of worlds. From this chaos, a pattern began to emerge. The heavier elements, iron, nickel, sank toward the center, forming the planet's core. Lighter materials floated upward, creating a crust that cooled, cracked, and shifted. Volcanoes tore through the surface, exhaling the first atmosphere. A toxic blend of gases that would one day give birth to clouds and rain. It is strange to think that every calm breeze, every soft rainfall began as an act of violence. The Earth we know was shaped by collisions and explosions, by pressure and heat. And yet, through that long storm, balance found a way. Water condensed from vapor and fell for centuries, filling the first oceans. Lightning flashed through those thick clouds, striking the waves, and in that brief spark, somewhere, somehow, chemistry crossed the line into life. For billions of years, the planet has held this balance, fragile but steady. Its core turns, keeping the magnetic field alive. Its crust drifts, recycling continents and mountains. Its orbit, slightly tilted, creates the seasons. It seems eternal, yet it is not. Every layer of the Earth, every cycle of wind and tide is a movement toward change. Nothing in the universe stands still forever. Deep beneath our feet, the planet's heart still burns. The core is as hot as the surface of the sun, a sphere of molten iron spinning inside a solid shell. From it rises the energy that drives tectonic motion, the slow, patient movement of continents. The continents drift like rafts over molten rock, colliding to build mountains, pulling apart to open seas. To us, it feels motionless, but to the Earth, this is breath. And with that breath comes impermanence. The mountains that seem eternal will one day crumble. The oceans will shift their basins. The air we breathe will change its composition again, as it has many times before. Even life itself is only one brief chapter in the long story of the planet. If we could compress the history of Earth into a single day, humans would appear only in the final second before midnight. Before that second, the planet was already ancient, shaped by forces beyond imagination. Entire worlds of creatures rose and vanished long before we arrived. Trilobites, dinosaurs, forests of towering ferns. Their bones became stone, their lives became coal and oil. The ground beneath us is not still, it remembers. The first great extinction was not caused by life, but by the planet itself. When volcanoes in ancient Siberia erupted for millions of years, they filled the air with ash and carbon, choking the atmosphere. Oceans turned acidic. Most living things perished. Later, another disaster came from above. A meteor struck the Yucatan, releasing more energy than all the nuclear weapons ever built. The sky darkened, fire rained down, and the great age of reptiles ended. The Earth has ended many times, and yet each time something new has begun. Life returned, reshaped, evolved. Each extinction carved space for a new kind of world. And so, our own existence rests on the ruins of many forgotten Earths, but every cycle has a limit. the same forces that sustain the planet also guide it toward its eventual end. The heat inside is finite. The magnetic field weakens slowly over time. The continents will merge again into a single land mass, a supercontinent, in the distant future before breaking apart once more. The sun's light, so gentle now, will grow hotter. The air will change. The oceans will rise and then vanish. Even now, the signs of motion continue. Under the calm surface of the Earth, the crust floats on molten currents. Pressure builds, and sometimes it breaks through, volcanoes releasing the memory of the planet's birth. Every eruption is a small echo of that first fiery dawn, a reminder that creation and destruction are the same process, separated only by time. The atmosphere that once formed from volcanic gas still evolves. It began as poison, carbon dioxide, methane, ammonia, but over eons, life reshaped it. Plants exhaled oxygen, turning death into breath, transforming the sky into something living. But that same balance could one day fail again. If volcanoes outnumber forests, if oceans lose their plankton, if the carbon cycle slows, the air could change once more. To the planet, these transformations are not disasters, they are evolution. Each age has its own air, its own oceans, its own light. We live in one of those ages now, a brief and temperate pause between extremes. It feels permanent because we are small and our lifetimes are short, but the planet thinks in aeons. If you could watch Earth from afar, sped up over millions of years, you would see continents drift like slow clouds, mountains rise and vanish, ice spread and melt, seas come and go. It would look alive, not in the way we are alive, but in its own vast rhythm. And somewhere within that rhythm is the seed of its ending. The Earth will not end suddenly, but in stages, as all living things do. First, its internal heat will fade, volcanoes will quiet, mountains will stop growing, the crust will become still. Without its inner motion, the magnetic field will weaken. The shield that deflects cosmic radiation will falter, and the atmosphere will slowly erode into space. Then, as the sun brightens over billions of years, oceans will begin to evaporate. Water vapor, itself a greenhouse gas, will trap more heat, accelerating the process. Seas will shrink to salt plains. Clouds will thin. The sky will fade from blue to pale white. The last raindrop will fall, and silence will return to the surface. But that is far ahead, billions of years from now. For now, the Earth continues its slow, graceful spin, still carrying rivers, forests, and cities across its back. The winds blow, the tides move, the planet breathes. It is alive in every sense that matters. And yet, when we look closely, we can already see the beginning of change, the faint tremors of an ending that is not destruction, but transformation. The same cycle that brought us here will carry us beyond. In this first moment of reflection, the Earth is not dying. It is simply living toward its next form. The heat that once made it molten still burns within. The gravity that bound it from dust still holds it steady. The planet has no fear of endings, for it has known them before. Every stone, every ocean wave, every gust of wind is a memory of fire, of ice, of time. And when the last story of Earth is told, it will not be of loss, but of return. The atoms that built it will scatter through space to build again. The dust of our world will seed new stars. The end of Earth is not extinction, it is continuation. Just as the beginning came from chaos, the end will lead to creation. Everything that was once Earth will live again, not as a planet, perhaps, but as part of something larger. Beneath the solid crust we walk upon, the Earth is alive with motion. It is easy to forget that the ground beneath our feet is not still, that continents drift like rafts on molten seas, that the stone mountains and quiet valleys we see are only the surface of something deeper and restless. Inside, the planet turns and folds and breathes, slowly, endlessly. The core, that glowing heart of iron and nickel, spins like a heavy, radiant wheel. Around it, the molten outer layer moves in vast currents, creating electric fields, and from those, a magnetic field that shields all life above. Without that invisible shell, the sun's radiation would strip the atmosphere away, and the surface would be as lifeless as Mars. But this protection comes with a cost. The heat that drives it is the same heat that shakes the ground, tears the crust, and brings fire to the surface. It is both the planet's heartbeat and its fever. Every mountain, every island, every continent was born from that inner fire. The crust is broken into plates, immense slabs of rock that float on the semi-liquid mantle below. These tectonic plates move only a few centimeters each year, but over millions of years, their motion builds and destroys worlds. When plates collide, one sinks beneath the other, melting into magma. When they pull apart, new crust forms from the deep. The surface of Earth is a living puzzle, always rearranging itself. This motion is what keeps the planet dynamic. It recycles carbon, builds continents, and renews life. But it also holds the seeds of destruction. At the boundaries of these plates, pressure builds silently for centuries. Rocks bend and strain until they can bear no more, and then they break. In that moment, energy locked in the crust is released as an earthquake, shaking mountains, cities, and oceans. The ground ripples like water, bridges sway, and entire landscapes shift in seconds. The largest quakes have changed history. One such rupture in the Pacific, thousands of kilometers long, lifted the ocean floor and sent a wall of water, a tsunami, racing toward the coast. It moved faster than a jet, rising as it reached land, swallowing harbors and fields. The wave that begins in silence can cross entire oceans, carrying destruction that seems endless, and yet beneath the fear there is still order. Earthquakes are not chaos, they are release. They are how the planet eases its tension, how it prevents greater fractures. The Earth cracks so that it does not shatter, but deeper still lies an even older force, volcanism. Volcanoes are the planet's oldest breath, the memory of its fiery birth. Every eruption is a message from the interior, a whisper from the molten mantle that still churns beneath. When magma forces its way upward, it melts stone, pushes through fissures, and bursts into light. From the surface, it looks like destruction, fire, ash, and smoke. But in truth, it is renewal. The land itself is being remade. Islands like Hawaii, Iceland, and Japan were born from this process. The black rock of new lava will one day turn to fertile soil. Forests will grow, animals will come, and life will take root again. Destruction and creation are the same motion seen from two different points in time. Yet the Earth's inner fire can also grow too strong. Beneath the crust lie chambers of magma the size of continents, supervolcanoes, capable of altering the planet's climate. One such caldera rests beneath Yellowstone in North America. Most of the time it sleeps, its heat rising gently through the ground in geysers and hot springs. But every 100,000 years or so, it erupts with a violence beyond imagination. When that happens, billions of tons of ash fill the atmosphere, blocking sunlight for months. Temperatures drop, crops fail, species vanish. The world cools into what scientists call a volcanic winter, a shadow of the sun cast by the Earth itself. These events have happened before. 74,000 years ago, the eruption of Toba in Indonesia may have brought humanity to the brink of extinction. The skies darkened, rain turned to acid, and global temperatures fell by several degrees. Only a few thousand humans may have survived. The Earth has carried such wounds many times. Each scar in the crust, each layer of volcanic ash buried in stone tells the story of catastrophe. Yet even these great fires are part of a deeper balance. Without volcanism, the planet's carbon would remain trapped underground. The air would thin, the oceans would freeze, and life would vanish in a slow, quiet suffocation. So the planet destroys itself to stay alive. But every source of energy fades. The heat that fuels this motion comes from the decay of radioactive elements within the Earth: uranium, thorium, potassium, left over from the planet's formation. Over billions of years, that heat will dwindle, the mantle will stiffen, the plates will slow, and tectonic motion will stop. When that day comes, the planet's surface will grow still. Volcanoes will die, mountains will cease to rise, the continents will lock into place, weathering slowly under the wind and rain until they wear down to plains. The oceans will creep across the flat world, and the once living crust will cool into silence. Without tectonic motion, the carbon cycle will collapse. Carbon dioxide will no longer be released from the mantle, and photosynthesis, the breath of life, will weaken. The planet's ability to regulate its temperature will fade. Over millions of years, the climate will swing wildly, then stabilize into stillness, a permanent calm. But it will be a calm without life. Even before that long stillness, there will be other signs. The magnetic field powered by the spinning core will weaken. Already it wavers, sometimes flipping, sometimes fading. These reversals have happened many times in history, but in the far future, when the core cools enough to solidify, the field will vanish for good. Without it, the solar wind will strip away the upper atmosphere, molecule by molecule. The air will thin, the sky will darken, and the planet that once held seas and forests will slowly become like Mars, bare, red, and cold. It will not happen suddenly, but gradually, invisibly, through ages too long for any witness to see. The continents will drift their last, the mountains will become ghosts, the earth will stop breathing, and yet even in that stillness, there will be beauty. The frozen volcanoes will gleam in the sunlight like glass. The air, thin and pure, will shimmer with cold light. The rocks will whisper with the memory of motion. If you could stand on that future earth, you would see no clouds, no waves, no birds, only the slow dance of shadows across a world at peace. The sun would shine brighter, its light sharper, the blue of the sky gone. The ground beneath your feet would be silent, but inside that silence, the memory of everything that came before would remain. For now, the planet is still young, alive with warmth, trembling with life. Earthquakes still reshape the land, volcanoes still breathe, mountains still rise. The same energy that will one day fade is still here beneath every step, ancient and eternal. The story of Earth is not only one of creation or destruction, it is both, forever intertwined. The end is already written, but it is written in patience, in time measured not by centuries, but by billions of years. The planet does not fear its fate. It moves toward it with grace. And as it does, it continues to make life possible. Every leaf, every storm, every ocean wave a gift from the same forces that will one day bring it to stillness. The fire that will end the earth is the same fire that gave it breath. Far above the thin veil of air that wraps our world, space stretches silent and eternal. The night sky seems calm, its stars steady and still. Yet behind that quiet, the universe is always in motion, restless, full of drifting fragments, invisible radiation, and collisions that shape worlds. The Earth, floating like a small blue island in this dark ocean, is constantly exposed to what lies beyond. Every day, countless pieces of dust and stone fall through the atmosphere, burning into streaks of light we call meteors. Most are no larger than grains of sand, vanishing in an instant. But among them drift larger bodies, asteroids, comets, remnants from the time when the planets were born. They move through the solar system in long, looping orbits, pulled by the gravity of the sun and the planets, ancient wanderers on silent paths. Occasionally, one of these objects crosses the path of Earth. When that happens, the result depends on size, speed, and chance. A small rock will burn up harmlessly. A larger one can change the course of life. The scars of those encounters are written across our planet. If you could strip away the forests and cities, the oceans and ice, you would see enormous craters scattered across the continents, circular depressions carved in an instant by impacts beyond imagination. Each one is a reminder that life on Earth is not only shaped by its own nature, but by the universe around it. One of the most famous of these scars lies in Mexico, beneath the shallow waters of the Yucatan Peninsula. It is called the Chicxulub crater, and it marks the end of an era. 66 million years ago, an asteroid roughly 10 kilometers wide struck Earth at a speed of more than 20 kilometers per second. In a moment, the sky turned to fire. The energy released was greater than billions of atomic bombs. Mountains vaporized, the sea boiled, forests burned across the globe. The shockwaves circled the planet, followed by a storm of falling debris. The air grew thick with dust and ash, blocking the sun. For months, daylight disappeared, temperatures plummeted, photosynthesis stopped. The food chains that fed dinosaurs, mammals, and even the smallest plankton collapsed. In a geological instant, 75% of all species were gone. It was not the first time, and it will not be the last. Smaller impacts happen constantly, some only meters across, others the size of houses or mountains. In 1908, a meteor exploded above the Siberian forest near Tunguska. It never struck the ground, but the airburst flattened 80 million trees across 2,000 square kilometers. In 2013, a much smaller meteor burst above Chelyabinsk, shattering windows across an entire city and injuring hundreds. With its shockwave, these are small reminders, glimpses of what greater impacts can bring. Astronomers call these objects near-Earth asteroids, fragments of rock and metal that pass close to our orbit. Thousands have been discovered, but many remain unseen, hidden in the glare of the sun or the dark beyond Mars. Space agencies track them tirelessly, mapping trajectories, calculating probabilities. The odds of a catastrophic impact in any single century are small, but in the deep timescale of Earth's life, they are certain. Even an asteroid only a few hundred meters wide could erase a nation. One several kilometers across could erase civilization. And yet, the planet itself would survive. The biosphere might burn, the skies might darken, but in time, green would return. Life is stubborn. It finds a way to rise from ash, but not all cosmic threats are so visible. Beyond the orbit of Neptune lies the Oort cloud, a vast sphere of icy bodies, the birthplace of comets. When a passing star or gravitational shift disturbs this frozen halo, a few of those comets fall inward toward the sun. Their orbits can take thousands or millions of years, and they come from every direction, making them harder to predict than asteroids. A comet approaching Earth is a ghostly sight. a nucleus of ice and rock trailing a luminous tail of vapor and dust. But beauty and danger often share the same form. If such a body were to strike, its icy mass would release a blast even greater than rock, vaporizing oceans, sending shockwaves through the mantle and filling the atmosphere with steam that would rain down as boiling storms. Throughout history, comets have been seen as omens, symbols of change, of endings and beginnings. Ancient civilizations watched them with awe and fear, not knowing that their glow was sunlight reflecting off ice, or that their paths stretched far beyond imagination. In a way, those fears were not wrong. Comets have indeed ended worlds, reshaped species, rewritten the story of Earth many times. Yet even they are part of a greater pattern, destruction that allows renewal. Without those ancient impacts, mammals might never have risen. Without the extinction of the dinosaurs, humans might never have come to be. The line between tragedy and creation is thin in the universe, but some threats come from farther still, not from within our solar system, but from distant stars. There are explosions so vast, so brief, that they can erase planets from light years away. They are called gamma ray bursts, the death cries of massive stars collapsing into black holes. In a fraction of a second, they release more energy than the sun will in its entire life. If one were to occur nearby, within a few thousand light years, its radiation could strip Earth's ozone layer, exposing the surface to lethal ultraviolet rays. No fire, no impact, no sound, just light, invisible and silent, washing through the planet and changing everything. Astronomers believe one such burst may have caused an extinction hundreds of millions of years ago. We have no way to predict when or where the next will happen. They are rare, but time is patient. The universe has forever to wait. There are other dangers too, quieter but inevitable. Stars drift through the galaxy like ships on a vast sea. Over tens of millions of years, one could pass close enough to disturb the Oort cloud again, sending comets toward the inner planets. Or perhaps a supernova, a nearby star's explosion, could bathe Earth in cosmic rays, damaging the atmosphere and altering life below. We live in a universe where distance and time protect us, for now. But nothing remains still. The solar system moves through the galaxy moves through space, and every orbit eventually crosses another. And yet, in this knowledge, there is not only fear, but perspective. The same cosmic forces that can destroy also gave us everything we know. The elements in our blood, the oxygen we breathe, the calcium in our bones, all were forged in the hearts of ancient stars, released in explosions just like those that might one day end us. The universe creates through destruction. Stars die to make planets. Planets burn to give life. Life flourishes and fades, feeding the next generation of stars and worlds. So the question is not whether Earth will end, it is how it will transform. Whether through slow fading or sudden fire, the matter that makes our oceans and mountains will return to space to begin again. And in that sense, there are no true endings. Even if an asteroid one day strikes again, or a burst of light washes across the planet, or the sun itself swells to consume us, the atoms that once formed the Earth will not vanish. They will drift, merge, and reassemble into something new. The universe wastes nothing. The end of Earth, when it comes, will be another beginning written in another sky. Throughout its long history, Earth has ended many times, not in the sense of vanishing into space or crumbling into dust, but in the quiet, recurring rhythm of extinction, the sweeping away of one age to make room for another. The story of our planet is not a straight line of progress, but a series of collapses and renewals, each shaped by catastrophe. 5 times, perhaps more, life on Earth has come close to disappearing entirely. Each extinction was both an ending and a beginning, the close-in of one chapter of evolution and the slow birth of another. The first great dying began in the oceans. 440 million years ago, the planet cooled abruptly. Glaciers spread across the continents, locking water into ice. Sea levels dropped, exposing reefs and shallow seas that had teemed with life. The creatures of that ancient ocean, trilobites, corals, and early fish, found their homes turned to deserts of stone. As the ice advanced, oxygen levels fell, and more than half of all marine species vanished. When the glaciers finally melted, the survivors began again, adapting to a colder, more unpredictable world. The second extinction was born of fire, not ice. 375 million years ago, volcanoes erupted for centuries, poisoning the air with carbon dioxide and sulfur. The oceans became stagnant, their waters stripped of oxygen. Whole ecosystems suffocated. The once thriving Devonian seas, home to armored fish and coral forests, fell silent. It was as if the planet exhaled too deeply and forgot to breathe again. But the most devastating of all came much later, an event scientists call the Great Dying. 250 million years ago, the Earth convulsed. Vast fissures opened across what is now Siberia, spilling lava across millions of square kilometers. The eruptions lasted for hundreds of thousands of years, releasing enough carbon to change the chemistry of the atmosphere and oceans. Temperatures soared, acid rains fell, and the seas turned toxic with methane and hydrogen sulfide. 95% of marine life and 70% of land species perished. Imagine a world where forests burned without end, where the air shimmered with heat, where even the insects, the most resilient of all creatures, disappeared. That was the end of the Permian Age. For millions of years afterward, the Earth was nearly silent. But eventually, green returned. Ferns spread first, then trees, then new forms of animals. From extinction came renewal. Later, during the age of dinosaurs, the planet's balance shifted again. The climate grew unstable. Sea levels rose and fell. Continents drifted apart. New life flourished. Giants that walked and flew. Creatures that filled every niche of land and water. The Earth seemed alive in a way it never had been before, lush and full of motion. And then, one day, a rock from the heavens ended it all. When the asteroid struck 66 million years ago, it erased an empire of life that had lasted for more than 100 million years. But in the ashes, small creatures, mammals, birds, tiny plants began to rise. The forests grew back, the air cleared. The world was not destroyed, it was transformed. Even now, deep in the soil and stone, the record of those extinctions remains. Layers of ash, sudden gaps in fossils, shifts in carbon and oxygen. The planet remembers every loss. And perhaps it remembers one more, the one that is beginning now. Unlike the great extinctions of the past, this one comes not from volcanoes or asteroids, but from life itself, from us. In a few centuries, humanity has changed the composition of the air, warmed the oceans, and moved more rock and soil than any natural process since the last ice age. Forests that once stretched across continents have been cleared. Species vanish faster than ever before. The delicate balance that took billions of years to form now trembles. Some call this the sixth extinction. It is quieter than those before, no firestorms, no falling sky, but its reach is deeper. It moves through climate, through chemistry, through the invisible threads that connect every living thing. The oceans, which have always been the planet's lungs, grow heavy with carbon. Coral reefs, the rainforests of the sea, bleach and crumble. Ice melts at the poles, raising seas that creep into the land. Weather grows more erratic, storms more fierce, droughts more cruel. It is not the end of Earth, but a great reshaping, one in which our species plays both creator and destroyer. And yet, as before, there is resilience. Life has always found a way to adapt, to evolve beyond its own disasters. The forms may change, forests of new kinds, oceans filled with strange creatures, deserts blooming with unexpected life, but the essence continues. The planet endures by becoming something new. Extinction is not a failure of life. It is part of life's rhythm. Each wave of loss makes space for invention. Each silence prepares for another song. If you could stand above time and watch the Earth's history unfold, you would see this cycle repeat. Growth, bloom, collapse, renewal. It is the heartbeat of the planet, slow, patient, eternal. And within that rhythm, one truth remains. Endings are never absolute. They're simply transformations too vast for any single generation to comprehend. The dinosaurs, the ancient fish, the forests that burned, none are truly gone. Their atoms are still here, scattered through the soil, the air, the sea, even through us. We carry the memory of every world that has ever been. And one day, when our own age ends, we too will become part of the Earth's next form, matter returning to motion, silence turning to song. The planet does not mourn its past. It remembers, transforms, and moves forward, always forward. For most of its history, Earth has shaped life, but in this brief and astonishing moment, life shapes the Earth. We are the first species to hold that power, the ability to alter the atmosphere, the oceans, and the rhythm of the planet itself. It is both miracle and burden, creation and consequence. When the first humans walked the plains of Africa, the Earth was already ancient. The continents had taken their familiar forms, forests covered half the land, and ice crowned the poles. We were small then, one species among many, dependent on the moods of weather and the migrations of animals. The planet seemed immense, untouchable, eternal. But slowly we began to leave marks. A fire lit to chase the night spread to clear the fields. A stone reshaped to hunt became a tool to carve, to build, to transform. We learned not only to adapt to the Earth, but to command it. And that was when everything changed. When the first forests were cut and the first fields planted, we altered the balance of carbon and air. When the first cities rose, we began to shape landscapes faster than rivers and glaciers. And when the first engines burned, the planet entered a new age, one not of geology, but of humanity. Scientists call it the Anthropocene, the age of humans. It began quietly, as all ages do, but its reach has grown far beyond our imagining. Each invention brought light, comfort, and connection, but also noise, heat, and exhaustion to the natural world. We have changed the color of the sky. From the glow of our cities, night itself has retreated. We have changed the chemistry of the air, filling it with invisible gases that trap heat like glass walls around the planet. We have changed the rhythm of the seasons. Spring comes earlier, winters grow shorter. Ice that once endured for millennia melts into the sea. We did not mean to become a force of nature, but every light, every flight, every harvest and engine and road has woven humanity into the deep systems of the Earth. We have become part of the atmosphere itself, a species whose breath and fire alter the weather. The consequences are subtle at first, a few degrees, a few storms, a few dry fields, but small changes accumulate, as they always do. The heat that builds in the oceans changes the flow of currents. The winds shift. The ice at the poles melts faster than it reforms. Each event ripples outward, touching coasts, forests, plains, and cities. Our atmosphere, the fragile skin that protects all life, grows thicker with greenhouse gases. The same carbon that once slept beneath the ground for millions of years now fills the sky, creating a blanket of warmth that the planet cannot remove on its own. This warmth is subtle but relentless. It melts glaciers that have never melted. It raises seas that flood the edges of nations. It fuels storms that break records, fires that burn forests meant to last centuries. The planet has endured greater changes before: volcanic winters, cosmic impacts, ice ages. But those took millions of years. This one is unfolding in centuries. Nature's rhythm has become ours, and it is moving faster than ever before. And yet, the Earth still adapts. The oceans absorb much of what we release. Forests drink in the carbon, growing faster, spreading farther north. But every system has a limit. When the oceans warm, they can hold less gas. When the forests dry, they burn instead of bloom. What once sustained the balance now begins to break it. Still, this is not a story of blame. It is a story of awakening. For the first time, a species has become aware of its role in the fate of a planet. We can see the future written in data, in rising graphs and melting ice, in coral skeletons and shrinking rivers. We know what is happening. That awareness, that capacity to understand, is itself an act of hope. We have changed the planet, yes, but we have also learned to measure those changes, to imagine alternatives, to design tools that might one day restore the balance we disrupted. We build mirrors to reflect sunlight, machines to draw carbon from the air, cities that breathe like forests. Whether these efforts will succeed, no one can yet say. But the very act of trying is proof of life's resilience. Perhaps it is not the end we fear, but the reflection. To realize that we are not separate from the earth, but made of it, that every breath we take is shared, every action ripples outward, is to rediscover humility. We are not its masters, we are its moment. Our species may be brief in the scale of time, but in that brevity, we have written light into the darkness, meaning into matter. We have looked at the stars and recognized our own origins there. We have built instruments that can hear the whisper of galaxies, see the birth of worlds, trace the chemistry of life in dust and flame. It is a strange kind of beauty to know that even if we vanish, our knowing will not. Somewhere in the structures we built, in the light we sent into space, traces of our story will endure. The Voyager probes drift beyond the sun's reach, carrying sounds and music and greetings from Earth. Long after the continents have changed, they will still be there, tiny messengers from a planet that once dreamed. But perhaps the deeper message is this: the Earth is not dying because of us. It is transforming with us. We are part of its cycle, another layer of its endless experiment. If our civilization ends, the planet will continue. Forests will grow through the ruins, rivers will carve new paths, species we cannot imagine will thrive in the aftermath. We often speak of saving the Earth, but the Earth does not need saving. It has survived ice ages, infernos, and voids. What we are really saving, if we choose to, is the part of the world that can still hold us. We are saving our place in its story, and that story is far from over. The planet will one day grow too warm for us, and life as we know it will fade. But the matter of our bodies, the thoughts in our minds, the works of our hands, all will return to the cycle. The atoms that compose us will scatter, join the soil, the water, the air, and, in time, the stars. We are the Earth thinking about itself. We are the part of its consciousness that can imagine its own ending and still find peace in it. Because endings are not failure, they are completion. The earth will outlast us just as it outlasted the creatures before us. And even as we vanish, the story will go on, slower, quieter, waiting for new voices to rise. In the far future, the earth will still turn, but the rhythm of its days will no longer belong to life. The forests will be gone, the seas shallower, the air thinner, the quiet hum of insects, the calls of birds, the laughter of human cities, all will fade into memory. What remains will be the planet itself, stripped down to its essence, returning to silence. The end will not come as a single moment. It will unfold slowly across eons, as if the planet were falling asleep. Even now, the process has already begun, invisible, patient, inevitable. The sun, the giver of all life, is also the agent of its end. Inside that vast sphere of fire, hydrogen fuses into helium, releasing the light and warmth that bathe our world. But fuel is finite, even for stars. As the hydrogen diminishes, the sun will gradually grow hotter, its brightness increasing by about 10% every billion years. It sounds small, but the Earth's climate is fragile, a delicate balance of gases, water, and distance. A slight rise in solar output will tip it beyond what life can bear. In less than 1 billion years, the oceans will begin to change. Evaporation will accelerate. Clouds will grow thicker, reflecting sunlight for a time. But the water vapor they release will trap more heat, feeding the cycle. The greenhouse effect, once a tool of life, will turn against it. The air will grow heavy with moisture. The seas will shrink. The continents will bake beneath a relentless sky. At first, it will seem gradual, a few degrees warmer each century, a few more deserts spreading across the land. But in geological time, it will happen suddenly. Within a few 100 million years, the last patches of open ocean will boil into mist. Rivers will fade into canyons of salt. The once blue planet will turn pale, its clouds thinning to ghostly wisps. Without oceans, the carbon cycle will break. The air will lose its balance of oxygen and carbon dioxide. Plants will wither. Photosynthesis will stop. The forests will collapse into dust, and the animals that depended on them will follow. The last life may endure in the shadows, microscopic organisms clinging to underground water or high in the thin layers of the upper atmosphere where temperatures are still tolerable. But even those will vanish as the air continues to thin and the temperature rises. In time, Earth will become a world of rock and heat, a second Venus, its surface an expanse of dry basins and shining plains of glass sculpted by the sun's fury. The atmosphere will thicken with steam and carbon, turning the sky into a haze of gold and amber. Winds will howl across empty continents, and where once there were cities and forests and oceans, there will be nothing but silence and light. Yet even in this silence, beauty remains. The mountains will still rise in slow grandeur, shaped by the last movements of the crust. The sun will still climb above the horizon each morning, brighter and whiter than before. Shadows will still stretch across the barren plains. The earth will continue to spin, faithful as ever. If someone or something could stand here then, they would see a world both familiar and strange. They would see the continents reshaped into one vast landmass surrounded by shallow, evaporating seas. They would see the sky filled not with clouds, but with the shimmer of heat, a mirage that dances endlessly on the horizon. They would see no green, no blue, only shades of rust and gold carved by the last breath of wind. The oceans that once covered 70% of the surface will exist only as memory, trapped as vapor in the atmosphere or as ice deep below ground. Without their weight, the planet's rotation will slow slightly, the days lengthening again. The moon, still drifting farther away, will no longer tug the tides, for there will be no tides left to move. In this future world, the sun will be a different star. No longer the gentle yellow orb of our time, it will blaze white and fierce, its corona reaching farther, its heat more intense. The temperature at the surface will climb past the point where rocks soften. Mountains will flow like wax, reshaping themselves over thousands of years. Iron will melt, sand will fuse into glass, earth will glow again, not from life, but from heat. It will shine faintly in the darkness, like a coal that never cools. But the end of life does not mean the end of story. Even as the surface burns, deep beneath, the planet's core will continue to turn for a while, keeping a trace of its magnetic field alive. For millions of years, the memory of motion will remain. Eventually, even that will fade. The core will cool, the field will die, and the solar wind will begin to strip away the atmosphere, molecule by molecule. The Earth will lose its veil of air, its ocean of blue. The sky will fade to black, and stars will once again shine at midday. It will become, at last, a quiet world, a sphere of stone and metal orbiting a sun too bright to sustain life. But though it will seem barren, it will not be meaningless. For in that dust, in those atoms, lies the memory of everything that ever lived. Each grain of sand will once have been part of a mountain, a tree, a creature, a thought. Each molecule of water, now gone to the sky, will have passed through rivers, clouds, and the veins of living beings. The planet will carry all that history within it, etched in the chemistry of its crust, in the patterns of its rocks. And far beyond, perhaps among the stars, descendants of humanity, or other beings who inherited our legacy, may look back at this glowing ember and know, once there was life here. Once this place was blue. The end of Earth as a home for life will not be a tragedy. It will be a natural step in the evolution of the cosmos, for even as our world fades, the sun will give birth to new elements, new energy, new possibility. The same forces that destroy will one day create again. The dust of our oceans will drift into space, joining the interstellar clouds that form the next generation of stars and planets. In time, new worlds will be born, and perhaps somewhere another sky will turn blue, and another kind of life will rise to wonder about its origins. This is the cycle that has no end. Life and death, planet and star, fire and silence, all part of one great motion. Earth's story is only one verse in that eternal song, and even when it falls quiet, the song will continue. The sun has always been our guardian, a star of gentle power, giving light, warmth, and rhythm to every living thing. But every star has a lifespan, and the same nuclear fire that sustains it also writes its fate. The story of the sun is the story of time itself, steady, radiant, and destined to fade. Right now, in this quiet age, our star is in the middle of its life. It burns hydrogen in its core, fusing atoms into helium and releasing energy that streams outward as light. Every second, it converts 4 million tons of matter into pure energy. That is what paints the skies, drives the winds, and sustains the oceans. But deep within, something is changing. As hydrogen runs low, helium accumulates. The balance between gravity pulling inward and heat pushing outward begins to shift. The core contracts slightly, increasing pressure and temperature, igniting new reactions that burn hotter and faster. Over hundreds of millions of years, the sun will brighten. Its light will become harsher, its heat more intense. The delicate balance that has nurtured Earth's life will unravel. The blue planet will dry, the air will thin, and even stone will yield to fire. When the last trace of hydrogen is gone, the real transformation will begin. The sun will enter its death throes, not in an explosion, but in a vast, slow bloom. The core will collapse further, igniting a shell of hydrogen around it. In response, the outer layers will expand outward into space, cooling and reddening as they grow. The sun will swell into a red giant. Its radius will increase hundreds of times, reaching beyond the orbit of Mercury, perhaps even Venus. From a distance, it will look magnificent, a crimson sphere filling the sky, burning softly at the edges, its surface boiling with great loops of plasma. If the Earth still remains, it will no longer resemble the world we know. Its oceans will have long since vanished. Its atmosphere will be stripped away. The crust will crack and melt, turning the planet into a glowing ember. The moon, once bright in the night, will dissolve into that light, its orbit lost, its surface erased. From the planet's surface, if anyone could still witness it, the sun would fill half the sky. It would rise not as a disk, but as a horizon-to-horizon wall of red flame. The heat would be unbearable, rocks would flow like liquid, metals would vaporize into space. The very bones of the planet, its iron, its silicon, its carbon, would begin to drift away, atom by atom, into the solar wind. This will be the true end of Earth, not by collision, not by violence, but by absorption, by returning to the star that once gave it life. The Earth was born from the dust of ancient suns, and to stardust it will return. As the sun continues to expand, it will shed its outer layers into space, forming vast clouds of gas that glow like mist in every color: red, green, violet, gold. This will be a planetary nebula, a final act of beauty, the last breath of the dying star. The nebula will drift outward, its filaments shining for tens of thousands of years before fading into the interstellar medium. And at its center, the heart of the sun will remain, a small, dense core, no larger than the Earth itself, but containing half the sun's mass. It will no longer burn. It will simply glow, faint and white, cooling slowly over billions of years. This remnant is called a white dwarf. It will be silent, no fusion, no fire, no breath, just the afterglow of everything that once was. Around it, the ghosts of the planets will circle, Mercury and Venus gone, Mars frozen and lifeless, the outer giants drifting farther into the dark. Asteroids will continue to orbit, dust will gather in faint rings, and the debris of the solar system will move in endless stillness. If, by some miracle, any fragment of Earth survives, perhaps a piece of crust or a moon of rock, it will orbit this white dwarf like a relic, and on its surface, the atoms that once formed seas, forests, and creatures will sleep, cooled to crystal, waiting for eternity to pass. In time, even the nebula will fade. The gases will spread out, becoming invisible to the eye. The white dwarf will cool further, growing dim, changing from white to amber, from amber to red, and finally to black. At that stage, it will be what astronomers call a black dwarf, a star that has forgotten how to shine. But that time lies so far ahead that even the universe itself may change before it happens. Trillions of years will pass before the last warmth leaves that star. And by then, galaxies themselves may have drifted apart, their light scattered, their stars burned out. In this long perspective, the death of the sun is not tragedy, but transition. It is part of the life cycle of matter and the endless recycling of energy into new forms. The hydrogen that fueled our warmth will become part of space itself, mixing with the dust of other stars. From that dust, new suns will form, new planets will coalesce, and new skies will shine. If you could watch from afar, you would see beauty, not ruin. You would see the solar system bloom like a flower, scattering petals of fire into the cosmos. You would see the light of our sun join the vast glow of 1,000 others, each giving its energy back to the universe. Every world, every living thing, every molecule will one day become part of that great exchange. Nothing lost, everything transformed. So when the sun dies, it will not truly disappear. It will simply change shape, returning its elements to the cosmic ocean from which it once emerged. The end of Earth, the end of the sun, these are not endings at all. They are gestures in the same eternal rhythm. Stars are born, they shine, they fade, and from their remains, new stars rise. Life follows the same pattern, written in light instead of words. Even after our sun fades into silence, its energy will travel on. Every photon of light it ever emitted will continue across the universe, never stopping, never dying, carrying with it the memory of home. That light will touch other worlds, warm other skies, and perhaps one day be seen by other eyes, wondering as we once did about the stars. The earth will be gone, the sun transformed, but the story, the movement, the meaning will endure. The atoms that made the oceans, the stones, the hearts of living beings will scatter through space and someday gather again, perhaps in another world, under another sky, around another sun. This is how the universe remembers, not through permanence, but through repetition, not through survival, but through renewal. And so, even as our sun prepares in the far future to fall silent, it is not an end, it is a beginning written in fire. After the sun fades into a white dwarf, the solar system will enter a long twilight, a quiet era of drifting shadows and cold light. The planets, once warmed by golden rays, will continue to orbit their dying star, but their paths will be slower, their skies darker, their days unmarked by warmth. Where there was once a blazing dawn, there will be only a faint blue-white glow, the last breath of the sun reflected in ice and stone. For a while, the system will remain fragile but intact. Jupiter and Saturn will still turn with quiet majesty, their storms frozen, their colors muted. Uranus and Neptune, pale and distant, will circle slowly, wrapped in endless night. But the peace will not last forever. The pull of the white dwarf will remain strong, but time, long enough, unravels everything. The planets will begin to drift. Tiny gravitational nudges from passing stars or from each other will add up. Orbits will shift ever so slightly at first, then wildly. In hundreds of billions of years, the solar system will lose its shape. One by one, the outer planets may be thrown into deep space, freed from the faint gravity of their old sun. Jupiter might become a rogue planet, wandering between the stars, its frozen storms preserved like sculpture. Saturn's rings, once brilliant with sunlight, will collapse into dust. Its moons will drift apart, each following its own lonely path. The inner worlds will fare no better. Mercury and Venus will already have been consumed. Earth, if any trace remains, will orbit closer and closer to the faint star until tidal forces tear it apart. The fragments will form a thin ring of dust around the white dwarf, glowing faintly when stray starlight touches it. Even that ring will not endure. Over time, it will spread out, dissolve, and vanish into the dark. The solar system will become a system in name only, a scattering of debris, a few asteroids and distant comets, a dim star slowly cooling at the center. The space that once rang with sunlight and storms will fall silent, and yet, in the vastness of time, even silence is not permanent. The galaxy moves, its stars orbiting the core like fireflies around an unseen flame. As they drift, gravity tugs and bends their paths, sometimes drawing them close. A passing star could wander near the cold remnant of our sun, disturbing its debris, capturing a planet, or stealing one away. Nothing in the cosmos stays still. Over trillions of years, such encounters will reshape everything. White dwarfs will travel through space like sparks, faint, steady, eternal in appearance, but slowly cooling, fading toward invisibility. Some will collide and merge, reigniting briefly in a burst of new light before dying again. Others will wander alone, their ancient planets reduced to cinders and ice. If any intelligent beings exist in that distant era, not on Earth but somewhere else, they might look into the depths of the galaxy and detect the faint glimmer of our sun's remains. They might wonder what world once orbited there, what forms of life once gazed back at the stars. Perhaps, if they listen carefully, they might even receive an echo, the faint radio signals we sent into space long ago, still traveling outward like whispers of a vanished civilization. Eventually, even the Milky Way itself will change. Galaxies are not static. They drift, collide, merge, and reshape themselves. Already, our Milky Way and the neighboring Andromeda galaxy are on a slow collision course, moving toward each other at hundreds of kilometers per second. In about 4 billion years, long before the sun becomes a white dwarf, the two galaxies will begin to merge. From a great distance, the sight would be magnificent. Two spirals of light entwining, their arms stretching, stars scattering like sparks from a cosmic forge. Within each galaxy, stars will pass near one another, bending orbits, pulling systems apart, forming new clusters of light. The night sky will glow with streams of stars, ribbons of brilliance that stretch from horizon to horizon. But within our old solar system, the end will be quiet. By that time, the Earth will be gone, the sun transformed, and nothing will remain to witness the grandeur of the collision. Our star, now dim and cooling, will drift through the merging galaxies, a single ember in a storm of light. After the merger, the new galaxy, sometimes called Milkomeda, will settle into an oval shape. It will be brighter at first, full of young stars born from clouds of compressed gas. But over time, that gas will be spent. The birth of stars will slow, then stop. The galaxies will grow old, and still the remnants of our sun will persist, orbiting silently around the galactic core, surrounded by billions of others just like it, ghosts of stars, each holding the remains of once living worlds. In the farthest reaches of time, when even galaxies begin to fade, the universe will grow darker still. The background light between stars, once a warm sea of cosmic radiation, will cool and stretch until it is indistinguishable from nothingness. Black holes will wander, the void. White dwarfs will cool to black dwarfs. Planets, moons, asteroids, all will drift apart, their energy spent, their motion slow and cold. This will be the dark era of the universe, an age where no new stars are born, where light itself becomes rare, and time flows in near silence. In that age, gravity will be the last force to act. Black holes will consume what remains, stars, debris, entire solar systems, pulling them inward until even light cannot escape. But even black holes are not eternal. They too will fade, slowly releasing their energy into space as faint radiation until nothing but emptiness remains. And yet, within that emptiness lies a strange kind of peace. No storms, no collisions, no heat, only balance. The universe, after its long history of motion and light, will finally rest. For the matter that once made Earth, the sun, and every living thing will still exist, scattered through space in the most delicate form imaginable, individual particles floating endlessly. Every proton, every atom will continue its silent journey. Perhaps in ways we do not yet understand, those fragments will one day combine again, and the cycle will begin anew. Because the story of creation is not about permanence, but recurrence. From one universe to another, from one form to the next, energy flows without end. If there is a meaning in this, it is not survival, it is continuity. Our world, our sun, our galaxy, all of it are simply temporary expressions of a deeper pattern, a pattern written not in words, but in gravity and light. And so, long after our solar system dissolves into the dark, its memory will remain, imprinted in the structure of the universe itself, in the shape of particles, in the echoes of radiation, in the quiet hum of existence. Nothing truly ends. It only changes form. In the distant future, long after the galaxies have stopped making stars, the universe will enter its final age. Astronomers call it the degenerate era, an age of fading remnants where everything that burns has cooled and everything that moves slows toward stillness. There will be no more new suns, no more light born from the fusion of atoms. The last red dwarfs will flicker out, their warmth extinguished after trillions of years of slow, patient burning. What remains will be white dwarfs, neutron stars, and black holes, the ghosts of stars, silent and unblinking. The night sky will no longer be scattered with billions of lights. Instead, it will hold only a few faint points, the last stars glowing dimly in a darkness that stretches beyond measure. For a being existing then, the cosmos would appear eternal and quiet, as if frozen in thought. The remnants of the old galaxies, black dwarfs, cooling white dwarfs, and the dead cores of suns will continue to orbit the centers of vast, empty halos. Occasionally, two may collide, briefly reigniting with a flash of energy, a fleeting echo of ancient creation. But those moments will grow rarer until even that ceases. The atoms that once formed worlds like Earth will drift freely through space. Protons and electrons, the building blocks of everything, will wander alone. Their motion will be slow, their temperature near absolute zero, the lowest possible state of energy. The universe will have expanded so much by then that every remnant of matter will be separated by unimaginable distances. Galaxies will be torn apart by the accelerating expansion of space itself. Clusters will unravel, stars will drift into isolation. Even light, once able to cross the cosmos, will be stretched into invisibility, its wavelength longer than the size of galaxies. This is what cosmologists call the dark era, an age when no light can travel far enough to reach another star, another planet, or another observer. The universe will be vast but sightless, silent but infinite. Time, too, will lose its meaning. Without events, without change, there is no way to measure it. Seconds, years, and centuries will become indistinguishable. The cosmos will be a quiet sea, calm and endless, where existence continues without motion. And yet within that stillness, there will remain faint whispers of the old order, the slow decay of matter, the long breath of entropy. Protons, once thought eternal, may begin to break apart after 1034 years. If that happens, even the most stable atoms will fade into pure energy. Everything solid, everything structured, will dissolve into radiation. By then, the black holes will be the last active entities in the cosmos. They will rule the darkness, massive, invisible, and absolute. They will consume the remnants of stars, gas, dust, even light itself, swallowing everything that strays too close. For ages beyond imagination, They will endure, each one a silent heart of gravity holding the universe's last secrets. But even black holes are not forever. Stephen Hawking's work revealed that they leak energy, tiny particles escaping from their edges in what is now called Hawking radiation. It is a slow process, almost impossibly slow. For a black hole the size of the Sun, it would take 1,067 years to evaporate completely. For the giants at the centers of galaxies, the process may last 100 years or more. When that time comes, the last black hole will shrink, releasing a final sigh of light, a burst of energy that marks the true end of structure in the universe. After that, there will be nothing left that can shine, nothing left that can fall, nothing left that can remember. What follows is called the black void, the ultimate state of entropy. The universe will be thin, cold, and uniform, filled with faint radiation spread evenly across infinite space. Temperature will approach absolute zero. Motion will stop. If we could somehow exist in that age, if some form of consciousness could watch from within, it would be like floating in an endless ocean of peace. There would be no boundaries, no noise, no direction, only quiet, only the memory of what once was. And yet, even this silence might not be the final word. Some physicists suggest that quantum fluctuations, tiny, random ripples in the fabric of space, could spark new beginnings. In the deepest calm of the void, particles could appear, gather, and ignite a new fire. A new universe could emerge, blooming from the ashes of the old. In that vision, creation and destruction are not opposites, but parts of one infinite cycle. Each universe gives birth to the next, endlessly, each one with its own stars, its own worlds, its own forms of life that rise, wonder, and fade. Perhaps this has happened countless times already. Perhaps our universe is only one of many, each born from the quiet heartbeat of the last. If that is true, then nothing ever truly ends. Every sun, every planet, every creature is a momentary expression of an endless pattern, light folding into darkness, then into light again. The end of Earth, the death of the sun, the fading of galaxies, they are not losses, but transformations. They are the rhythm of existence playing on scales beyond comprehension. When viewed from far enough away, even death becomes just another shape of life. The universe breathes out, stars die, matter decays, energy spreads, and then, perhaps, it breathes in again, collapsing, condensing, and igniting once more. Each cycle might be slower than the last, each quieter, but the pattern continues, subtle and eternal. And even if it does not, even if this is the only universe destined to end in infinite night, it is still beautiful, because from that brief flicker of light and time, consciousness arose, eyes opened, beings wondered, planets dreamed, and for a moment, the universe saw itself. That moment, that awareness, may be the rarest and most precious thing the cosmos has ever known. Perhaps that is the true purpose of existence, not to last, but to awaken, to look upon itself and to know, if only once, that it is alive. So when the last light fades, when even atoms fall apart and time loses meaning, the universe will not be diminished. It will have already fulfilled its purpose. It will have witnessed itself, and that memory, even if unspoken, will echo forever. In the end, there is no sound, only the memory of sound. No light, only the afterglow of light that once was. The universe has grown vast beyond imagining, stretched so thin that distance itself has become meaningless, and yet, within this silence, something remains. Not matter, not motion, but pattern, a trace, the faint geometry of everything that ever existed, woven into the fabric of space. The stars may be gone, but but the imprint of their light still whispers through the void. It is the memory of creation itself, echoing forever in the structure of reality. If you could step outside time and look upon the universe from that final moment, you would not see destruction, you would see completion. Every particle has found its place, every force has balanced, every flame has returned to the dark that gave it birth. It would look like stillness, but in that stillness lies peace. The universe is not mourning its end, it is merely exhaled, and in that breath, it has released everything it once held. The stars, the planets, the lives, the dreams, the questions, all have been given back to the infinite. The matter that once made Earth, its stones, its seas, its creatures, its people, is scattered now through the endless dark. But scattered does not mean lost. Each atom still carries the memory of its journey. Some came from the hearts of ancient stars, some burned in the core of our sun, some belonged to the oceans that shimmered under moonlight, to forests that sang with wind, to hands that reached toward the sky. Those atoms now drift between galaxies, carried by no wind but gravity itself. They may never meet again, yet they remain part of one continuous story, a story written in energy, not in words, a story without beginning or end. Perhaps in a distant future beyond all futures, that same dust will gather again. Perhaps from the cold quiet of nothingness, a fluctuation will stir, a ripple in the dark sea of space. From that ripple, new particles will appear, new forces will awaken, and slowly, over time, new stars will ignite. It will not remember us. It will not know that it has happened before. And yet, in its atoms, in its pattern, it will carry the faint echo of this universe, of the earth, of the sun, of every life that ever looked up and wondered. That may be the greatest truth of all. Nothing is truly forgotten. Every act of creation, every moment of consciousness, every spark of light adds to the sum of what the universe is. When new worlds are born, they will be made of the same dust that once sang with oceans and lightning and thought. They will carry, in some invisible way, the trace of everything that came before. So perhaps there is no end, only transformation. The death of one universe is the dawn of another. The silence that follows the last heartbeat of time is not absence, but potential. The still moment before the next note begins. And if that is true, then we are not small and we are not lost. We are threads in a tapestry that no one weaves, but that never stops weaving itself. We are part of the universe's memory, a brief pattern of awareness within a greater, eternal whole. Even when the last light fades, the memory of light remains. Even when the stars fall silent, the pattern of their music continues in the fabric of space. And somewhere in another age, it may rise again. Imagine it, a new cosmos blooming in the dark, vast and newborn. In that first instant, everything that ever was becomes new once more. Space unfolds, time begins, and light, ancient and familiar, bursts forth again. It fills the emptiness, dances across the void, touches the dust, and says, as it has said countless times before, be. And somewhere within that young light, carried invisibly across eons, is the memory of our world, the soft blue planet that once circled a star called the sun, a planet that dreamed, that thought, that told stories to itself about beginnings and endings, a planet that looked up at the night sky and saw its own reflection in the stars. Maybe one day, in another universe, something will rise again, not exactly us, but something like us, something that will stand beneath a different sky and wonder where it came from, something that will feel the same strange pull to look upward, to ask, to dream. And when it does, the circle will be complete. Because that question, that longing to understand, is what connects all life across all worlds, across all time. It is the same question the first humans whispered to the night, the same question the stars answered with their silence. Where did we come from? What will become of us? And the answer, whispered softly back through eternity, is simple. You were never separate from the universe. You've always been part of it. You're made of its light, and when that light fades, you return to it. The end of Earth is not the end of us. We are the memory of stars, the imagination of atoms, the quiet dream of time itself. The story goes on.